begin with understanding conditional statements. What is a condition? Let's say you meet your father today and your father says that if you are about to get good grades in your examination, we would have a party today. So, what is the condition? Condition is getting good grades, and what is the conclusion? Conclusion is having a party. Now, these conditional statements are what are known as if-then statements. If you get good marks, then you have a party. Simple example that I can have, another one here from mathematics probably, is if there are two lines that are at right angle, then they are what? They are perpendicular, as simple as that. So this is again a if-then statement. So conditional statements are if-then statements, and this is a statement. Now this statement can be arranged or can be flipped in various ways. Now, how do we understand that? Today, we would be understanding the various ways under which I can flip this first statement that I said and create different meanings for it. So, let's say I have the statement if P then Q. So, my statement is if there is cloud, it rains. Okay. Now, the cloud and the rain is there, and that is the P and the Q. What I would do is, I would switch these, and that would change the statement. Now, what would be a converse statement? Converse statement would be if Q, then P. Now, these are the ways under which we denote it in logic. So, P to Q is the statement. I change the positions for P and Q, and what does it become? It becomes what? It becomes Q to P, and this is what? This is a converse statement. Not is denoted by this line, and you have if not P then not Q, which is an inverse statement, and if not Q then you would have not P, that is a contrapositive statement. And then we have a biconditional statement where the phrase between if and then, if I change the position, interchange the position of the two, the meaning won't change. And that is what is a biconditional statement. So we would understand each of those one by one. But the basic idea here, before we begin understanding these, is if I say my statement is true, then my contrapositive would be true, and in the other case, when I have the converse that is true, my inverse would be true. That is a very fundamental aspect that you would have to remember before we begin further, and this is what is known as logical equivalence. Statement is logically equivalent to contrapositive, and converse is logically equivalent to the inverse. How? Let's understand that in a while. So we take the first example, the conditional statement. So first example, I say if clouds, then what? Then definitely there is a rain. So this is a conditional statement where clouds is P and rain is Q. Now this is true. So if this is true, what would be true? The contrapositive would be true, which we would understand in a while. But before we go to contrapositive, let's move one by one. So this was my conditional statement, or the statement what we usually say. The next is the converse. So in converse, what I do is I simply change the position of what? Q and P. So if Q, then P. So I have the very simple concept, if there is rain, then there would be cloud. This is false. This is not true. I cannot say if there is rain, there would be cloud. Okay. So in that case, you have a converse statement. Now, if this converse, if I am saying is true, then my inverse would also be true. And what is my inverse? If there is no cloud, then there is no rain. But that is not really correct. Even when you do not see dark clouds in your sky, you still have rain. Okay, clouds here we mean by dark clouds. Okay, so this is a inverse. So converse and inverse are logically equivalent, and the statement if clouds then rain is logically equivalent to the contrapositive. That means if there is no rain, then definitely there are no clouds. That's why there is no rain. And that makes the statement if there are clouds, there is rain. So contrapositive is logically equivalent to what? The statement. And this is if not Q, then not P. I repeat again, if I say if there is no rain, that means there are no clouds in the sky, and that is equivalent to if there are clouds, there would be rain. Okay. So that is making contrapositive logically equivalent to the statement, converse getting logically equivalent to the inverse. The next further interesting is the biconditional. Now, biconditional, how do we understand it? We understand it with a simple logic. If two lines are at right angle, then they are what? They are perpendicular. Now, as I said, I switch the two phrases that are there. And I say, if two lines are perpendicular, then they are at right angle. So, either I keep the P at the starting or P towards the end, or I move from P to Q or Q to P. In both the cases, it is true. And therefore, it is biconditional. So, a simple logic under biconditional is, I can simply remove this if-then relationship and convert it to a relationship of if. IFF, that means if and only if. And I can read this statement as, two lines are at right angle if and only if they are what? They are perpendicular. And that makes the concept very, very clear. Now this is a quick understanding of the statement, the conditional, the converse, inverse and the contrapositive. Now let's have this table to understand. In this case, I have my P and Q, both of those are true. So what would be the negative of those? Both of those would be false. The inverse of P would be false. So not P would be false and not Q would be false. In conditional, I say P to Q. So that makes it true. Okay. And since the conditional is true, my contrapositive would also be true. But when you have both the statements, both the terms that are true, that is the hypothesis as well as the conclusion is true, my converse and inverse is also true. Similarly goes with false. When you have both the statements that are false, the negative of these would become true, and since the negative of these would become true, I would have the inverse and the contrapositive that would be true, and since both of these are false, you would have the conditional and the converse that would be true. So again, all of those would be true in this scenario. What would happen if my P is true but my Q is false? Then the not P would become false and not Q would become true. In this scenario, what would be the case? The case would be that my statement would become false. So my contrapositive would again be false, and since statement and the contrapositive are false, my converse and inverse would become true. And the reverse of it, if this P is false and Q is true, then their inverse would become what? It would become true and false, and this 2 would become false, and the conditional and the contrapositive would become true. So that is again a very simple way, a quick way to understand it, a quick essence of this lecture again. If the statement is true, the contrapositives is true, as we have shown them with similar colors here to help you better understand. And then if converse is true, then inverse would be true, again shown in the same color. Okay, so converse and inverse are logically equivalent, and conditional statement and contrapositive are again logically equivalent. So that is the basic idea of a conditional statement. Now, as we said, a conditional statement is a if-then statement. So whatever is after if is the hypothesis, and whatever is after then is the conclusion. So when we are talking about the conditional statements, we are trying to understand a hypothesis as well as a conclusion following a hypothesis, and we are seeing if the hypothesis is true, whether the conclusion is true, then what would be the kind of statement, whether the statement would be true or false. Okay, so that is what we have tried to understand in this quick summary of the table that we have done here. We would be coming up with many interesting lectures on logic, very interesting and very scoring indeed. So stay subscribed, stay tuned, have a wonderful day ahead.